You and a moving airplane. This is a related rate problem, which is an application of the derivative. Let's say you are staying on the ground and you're looking at an airplane that is moving away from you at the speed of 500 miles per hour at an altitude of 3 miles. Right, and then you're wondering how fast the plane's distance from you increasing at the moment when the plane is flying over an observatory that is 4 miles away from you. So we call the distance between you and the observatories is the distance x, and the distance between you and the airplane is distance y. Right? And the question is how fast the distance y is increasing. And we look at this figure, and we establish that the distance between you and the observatories is x. So then if you move yourself above the ground at the altitude of 3 miles, so then you have the same height as an airplane, then the distance between you and the airplane is also x, distance x, when you're at the same height. So using the fact that the speed of the airplanes is moving away from you is 500 miles per hour, that implies that the rate of change of the distance x in terms of time is also 500 miles per hour. Is the same. The rate of change of x in terms of t is the same as the speed of the airplane. All right, in mathematics, the question is, what is dy dt? So what is the rate of change of y in terms of t, where y is the distance between you staying on the ground with the airplane is flying away from you within altitudes of 3 miles. We see that the positions of the airplane, the U and the observatory forms a right triangle. And you can use the Pythagorean Theorem to conclude that, y squared equals to x squared plus h squared. So y is the distance between you and the airplane, x is the distance between you and the observatory, and h is the distance between is the altitude of the airplane, or the distance between the airplane and the observatory. So we asked to find dy dt given y squared equal to x squared plus h squared. We will think of implicit differentiation. So we apply d over dt to both sides, since x, y, and h are not the same as t. So then we have the derivative of the left side is 2y dy dt, and the right side is 2x dx dt plus 2h dx dt. Keep in mind that we know that the altitude is 3 miles, and this is constant, it's not changing. That means dh dt equal to 0. From this equation, we can solve for dy dt in terms of x, y, and dx dt. We know x equals to 4, h equals to 3 as always. X equals to 4 at that moment when the airplane is above the observatory. And using the Pythagorean theorem, you can solve for y, which is equals to 5. All right. Earlier, we figured that dx dt is 500. This is the same as the speed of the airplane. So putting all of this information together, we can find dy dt equals to 400 miles per hour. What does that mean? That means at the point when the airplane is flying over the observatory, the rate of change of the distance between you and the airplane, dy dt, is 400 miles per hour. So it's moving away from you with the rate of change of a distance of 400 miles per hour. Alright, thanks for watching this video. I hope that learning this application of the derivative will motivate you to take another math course. Enjoy!